All right. What's up, everybody? Welcome to Bootcamp session number 7. Today we're going to be going over Mongodb and Mongoose, and that's going to be a little bit more in the back end. So Mongodb is going to be the database we use for a lot of the the milestones in the project, and it's going to be used on most of the project teams, if not all of them as well. And then we'll get into it more today, but Mongoose is kind of how you kind of make queries on that database. So something like if you're familiar with SQL in a a relational database, Mongoose is going to be kind of something similar to that, but for NoSQL databases. So to get started, we're gonna today's agenda. What is MongoDB? Some CRUD operations, what that means, and then using Mongoose. I don't think there's any updates except for next Thursday. We're not going to have boot camp. It's a holiday, so take that time, enjoy it. Maybe work on the project milestone. But yeah, so no boot camp this Thursday, similar to like how it was last Thursday. No boot camp. And then there's also going to be a Chipotle Fundraiser. And that's going to be, I believe, next Tuesday. There should be a message about it on the Slack, but if you just go to Chipotle, you show them the flyer, Hack for Impact gets a portion of the profit. So love to see you guys all out there. And yeah, without further ado, does anybody have any questions about any of the material we went over last week? Sweet. So just a reminder of the schedule. Today we're on the 7th bootcamp session. There's only going to be 2 left. One's going to be going over advanced state and React, and that's going to be next week. And then unit testing, that's actually going to be an asynchronous one that we're just going to send out to everybody on the Slack. And we're doing that because we're going to be having a different social event, and we want to kind of get bootcamp finished up before I guess we leave for Thanksgiving break. So hopefully that should make things a little bit easier for you. But yeah, without further ado, we're gonna go and get into the usual Kahoot. And as always, feel free to like join up with a partner, play with the person next to you, play by yourself, doesn't matter, just a review. And it's gonna be over last week's material.
I don't even remember what questions I wrote. Could we like go over this? Actually, just gibberish. Who is HTTP?
Why is HTTP?
Where is HTTP?
When was? You could do that one.
What year?
When is HTTP?
Really obscure historical text. What is Babel? Nobody knows.
Who is Babel? Who's the collaborator who did Babel with Joseph Babel?
Who is our Lord and Savior, Joseph Babel? Give everybody a few more seconds to join in. Why is this never? I really wish we had the volume. I probably have to like hook it up to my computer, like share audio or something like that. Yeah. Maybe even in Zoom.
HDMI should carry
By default, yeah.
audio.
Sweet. So I think we're good to go ahead and get started. So yeah, it's just going to be a review on HTTP, APIs, and Express. My cursor's hovering over skip right now. Sweet. Good job, everybody. The speed demons of James and Ethan. Getting touchscreen is very. I feel like that's like the biggest advantage you can have. Ooh,
So an HTTP method, that's kind of how, when you're making like a fetch request, you're making an HTTP request, that's how you tell it, like the API what you want to do. So if you want to get data, if you want to post data, you can't API data. API is like, that's what you're interacting with, but it's not an actual method.
and we'll get more hands-on experience with this today as
Yeah,
well.
yeah.
So. You got some risers. It really is bare for boys. Recording it.
Nice. Yeah, so status code was the correct answer. That's like 404 not found, or is it 200 that's success?
Yeah.
Yeah. Both are going to have a body though, because you can send data to an API or you can take data and receive it from an API.
Even the is a good one. Let's just see the rules.
Ooh, nice job.
Good work, good work.
I guess, yeah, technically not all the good ones. So you do use await, but it's not a function. And fetch is like the actual function that's making the request.
I didn't know it was a default.
Yeah.
So if you don't
You
specify,
don't even need to set fire from the second off thing is completely optional.
it makes
Everybody
sense.
knew it.
It makes sense. Sweet, good stuff. If you have some explaining beyond the blue spelling.
So blocking is what happens when there's like a really time-consuming piece of code that like prevents any of the other code from running. If a promise isn't resolved, like you just kind of have garbage data. Like JavaScript will just keep on going. So you actually don't need to resolve a promise in order to prevent blocking.
Although I'd say it is a good practice
You
to
always
like
should, yeah.
check that your promise returns valid data. That's just going to save some issues later on. But yeah.
Ooh. Yeah, nice job. The async goes on like a function declaration, not on the variable, for the people that chose the green option. So that blue one is right.
Two left. Oh, come on. Sweet. And then should be one final question. I think you should go sabotage them. Click on the wrong ones. Make it interesting.
Man, it's hard to. There's no good way to say that. Oh. Yeah. You're gonna see a lot more of Express today, so we'll go over it then. But the first parameter is like the route you're going to, and then the second one is actually going to be a function. And the two inputs to those functions, to that function, is the request and the response.
That's a tricky one.
It's a tricky one.
The podium. Stuff Drew. Stuff Ryan Justice.
I wonder who won.
Well done. Well done. Okay. So hopefully that was fun. We're gonna be going over a lot more of this stuff in more detail today, especially Express, and we'll get a little bit more into some fetches, but that's not gonna be for a little bit. So without further ado, we should be good to go ahead and get started.
Okay, yeah. So first kind of topic we're going to go over is what databases are, and specifically what MongoDB is, which is kind of the database service that we're using for the milestone. So the reason that we need databases is that we need to be able to store information for a long amount of time. So right now, if you like updated the recipe list, like the ingredients list on your website, and then you refresh the page, like none of that stuff is saved. Like it's temporary data. Whenever you refresh or like close a tab, the data is gone and you're kind of resetting. But what a database allows us to do is it stores our data in like a separate place that kind of makes sure that changes to that data are always saved and you can easily access and change that data. Pretty much any web development project you're working on, you're going to need a database of some sort. And the most popular ones we're using are MongoDB, MySQL, which is like you'll hear SQL versus NoSQL a lot. MySQL is the big SQL database. DynamoDB, which is the AWS database, and Firebase, which is the Google Cloud database. We're going to be using MongoDB because it's free and pretty easy to use. So what is MongoDB? MongoDB is a NoSQL database, which means you don't have to learn the structured query language, which is like a whole nother syntax. And MongoDB is really nice to use because all of your data is stored in JSON. So all those objects you constructed from milestone 2, you can just shove those directly onto MongoDB, and there's no like additional formatting really you have to do. In MongoDB, we're going to be using a service called Atlas, and that's kind of the database as a service that hosts your database, which basically just means you don't have to worry about hosting and stuff like that. So the database kind of exists and you don't have to worry about like what computer is hosting it or how it's being run. You can just connect straight to it. So a brief overview of the structure of MongoDB. MongoDB, you have your database, and in that database, you have collections. And the collections have a group of objects. So, or a group of documents, I mean. So you can think about, if you learned like object-oriented programming before, the class would be like your collection, and then each like object you instantiate, that would be a document. So let's say if we are working with like recipes, then like a single recipe, like a pasta recipe would be a document, and then you would have a recipe collection because that's like your general data type. But you wouldn't have like an event and a recipe in the same collection because those are like two completely different data types. And then, as I said before, MongoDB stores all of the data in JSON. So this looks familiar because it is pretty much JSON. A couple small things to know. MongoDB, we do like type all of our fields. So like this, you can say like, oh, this field's always going to be a string, or this field's always going to be a number, or stuff like that. So there is a bit added structure. And then additionally, inside of JSON, you can have arrays, you can have nested JSON. So you can have lots and lots of data within a single object. Oh, one last final note there at the bottom. whenever you create a new document in MongoDB, it's going to automatically create like a unique ID. So that's going to be like added automatically to every single document you make.
Sweet. And the best way to learn a lot of this stuff is just by looking at actual MongoDB. So we'll go ahead, take a look at an Atlas account. And that's just going to be like how we see our actual data, because that's like the MongoDB's way of hosting it all on a server that we can easily see. So we'll just go straight into like what some data could look like. So if we go here, we can I'll actually go outer. I'll go to the outermost layer. And this is going to be what you'll see on your MongoDB. So you'll have a list of all of your projects. I guess for today, we'll just go over this one, milestone 4. You can create as many as you want using the free tier, and that's talked about in the milestone description for the next milestone, which is going to be kind of connecting your project to this actual database. So from here, inside of your database, you'll have these things called clusters. And I think you'll only actually ever need one cluster, and that's just going to be like where all of your data is stored. So if you don't have a huge amount of data, you'll probably only need one cluster. So some things you can do with a cluster is you can kind of set where your data is stored. So for us and our purposes, we're all in California. So we're probably going to want to store it on some California server somewhere. But if you have like a global app where there's people all over, you might want different clusters in different parts of the world, and you can kind of break it up like that so people will get access to their information quicker. And then if we go into our cluster, and then we'll see a bunch of different options. We'll see our overview, which will contain things like how many operations have been operated on your database. And then there's some other features. The main one for us, though, is going to be collections. And this is going to be where the actual data is stored. So as we saw in the example here, I don't know why it's so low quality, but I put in a lot of what this would look like. So we can see, and we'll actually go ahead and create one as well, just how this information is actually stored. So we have like our first name of Paul, last name Miller, phone number, city, cars, which is an array. We can drop that down and we're going to see it's an array of objects. So you can have a few different objects. You can have like your cars, and if you have 2 cars, you can have one represented as an object and have another one represented as an object. And each object could be something like have a model and a year. And one other thing to note about NoSQL is that all of the information doesn't have to be consistent. So if we wanted to, we could go ahead and like add another field here, which so I don't know, what else do cars have? Amount of wheels, I guess. I guess cars always have 4, but not always. And you can go ahead and see all of the options for different types. As Vance was talking about, all of your information is going to be typed. So wheels, we want that probably to be an integer, and 32 is just going to be a smaller version for if you're going to have typically smaller numbers, and that's just going to keep your storage size down. And then going back into this, there's also a profession. So, and that's going to be an array of objects. So there's going to be like banking, finance, and trader. And we can actually go ahead and update that wheels. And now our information will be up to date. And so that's one example, given this document structure here, just this example. But we can actually look at a model, a database model that's going to be like the one we're going to use in the project. So if we go back, we can look at a different collection and a different database, and that's just going to be the recipe DB. And we can actually take a look at some recipes and what that would look like. So here we'll start to see something that looks a little bit more familiar to us. I know like our recipe name, preview, description, all of those are probably going to be strings, but then we're going to have ingredients and steps. And this is just going to be like a brief overview of like how it's stored and what it looks like in here. It's going to look very similar to the JSON file you guys have all created in your last milestone. So something like recipe data, and then you'll like, whenever you guys create the React components, you'll read each one. And here we can see that there's a few different results. So there's going to be all of our, I guess, our simple caprese salad recipe is one document. Our loco moco is a different document, and pasta primavera is a third one. That should be a quick overview of MongoDB and how you'll use it. We'll get into actually connecting into it and like how you interact with it in a little bit. But hopefully this provides like a little brief sample of what it looks like, and we'll start to like make it look a little bit more familiar. Any questions about what like MongoDB is at this point? Sweet, and I'll just ask, have any of you used SQL databases before? And then have you used NoSQL databases, anybody? Sweet. So you have to kind of think of them as two different things. You can think of a database and that's going to store information somewhere, but a NoSQL database and an SQL database, they have like completely different way of being stored. The SQL databases are stored in tables, and you'll probably see that in some of your classes. Like I know in 365, you use SQL and relational databases, but something that's probably a little bit more modern and useful for a lot of the projects we're going to be working on is these NoSQL databases, and MongoDB is probably just the biggest example or the most used NoSQL database provider. So moving back to the slides.
Okay, cool. So now we're going to talk a little bit about Crud Operations and basically the different ways that we're going to be talking to the database in MongoDB inside of our code. So we're going to be using what are called Crud Operations, which are just the set of interactions we have to interact with our databases. So CRUD stands for create, read, update, and delete. And these are just the 4 basic actions we can take with any database to kind of talk to it on the internet. So we'll go through them one at a time and talk about what each one does. So we'll start with create. This is going to be kind of our most basic one where we start out with CRUD operations. So create is always going to be used to add a new document to the database. So, our database is always going to be totally empty when we start. There's no pre-existing data, so we got to create some documents and add them to that database using post HTTP methods that we talked about last week. So there are a lot of ways that you can do this, but a common way you'll see this in the front end is maybe users inputting information in a form, and then we're going to be taking that form information, sending a post request to the database, and then creating those documents with that information to store it for later. So kind of a quick example we have outlined here. Like Cole just said, the data is not actually stored in a table format like this. This is just kind of a convenient and easy way to visualize it. But if we have our events collection, so just a group of documents that are all different events, and we wanted to add a new event to it, say Hacksgiving, we would just create a new document, send that data in the body of a post request to our database, and then MongoDB would just add that new document with the Hacksgiving information in it into our database. So that just adds something brand new to our database. So our next thing is going to be read, which is pretty much the opposite of create. So it's going to basically get data from the database and do the data flow in the opposite direction, bring it from the back end to the front end for users to see. So this will be pretty common when we have a lot of data in the database that we need users to see on the front end that it's going to change over time, and it needs to be updated each time we use the website. So with read CRUD operations, we're going to be using the get HTTP method, which is where we're sending that method to the database and waiting for a body response of JSON data from MongoDB. So if we tried to get the Hacksgiving event, it would just return us that document 2 in the events collection with the JSON formatted Hacksgiving event information. And then next we have update. So this one specifically just allows us to update existing fields inside documents in our database. So a lot of times we're going to be having data that's constantly changing. It's not static, it's pretty dynamic. So update's really useful for us. So it's going to allow us to just modify certain aspects of individual documents rather than like creating entire new documents and doing more expensive operations like that. So we'll use a put HTTP method for this, and we'll just put the data that we want to change in the document inside of our request body. So in this example, again, we want to update the Hacksgiving document, change the topic from social to food, something a bit more interesting. We can just send that little bit of data to the database, and it's going to change the document that we already have in MongoDB. And then finally, we have the delete Crud operation. And this does exactly as it says. It just deletes a document from the database permanently. Kind of helps us. We want to do this kind of operation when we get larger databases. If we have a ton of documents, it's going to take longer to parse through that data. We have a bunch of stuff overflowing in the background. We just want to be sure to keep our data consistent and only keep what we need in the database. So we use the delete HTTP method, and then just whatever ID of document we would send in the body of our delete request, and it would just destroy that document from the database. So those are the 4 basic methods that we'll be using to kind of talk to our databases, interact with them, and kind of update the data that we need to be storing in there. And then before we hop into the demo, I'm going to quickly talk about Postman. It's a little bit of an aside of what we've been talking about today, but basically Postman is just a tool that we can use during development to test our HTTP requests without having to write full fetch requests and a bunch of extra JavaScript that is a little bit too much to do for one demo. And Postman is also super useful just in development in general to see if your HTTP requests are working and get data visualized super quickly and just without having to go through a bunch of extra coding that is a little bit superfluous. So we have a link to download it up there that will be on the Notion later. You don't have to download it right now for the demo, but we're just going to walk through it real quick and kind of show you how you can use it and how you can kind of visualize that data moving back and forth in the database. And then I think we'll hop into the demo now.
Sweet. So Postman is really useful when developing. You might not like see initially like why it's super useful by looking at it, but it allows us to do to kind of see our app without writing, or see some of the, like, I guess, test our backend code and all of our CRUD operations without having to actually write the front end for it. So like if we wanted to have, say, like update this in our database every time we added something, and like you'd have to write all of the front end code that's like, write a function, and then when this function happens, create a fetch request, and then that'll kind of take it to the backend where you can kind of handle that and actually like update by adding tests into your document. And by going over to Postman, which we'll take a look at now, we can actually kind of just skip all of that part that I kind of just went over in the front end, and we can just kind of test our code that we write in the back end. So by looking at like our MongoDB account, we'll use kind of the demo we went over a little bit earlier as an example, and we'll kind of go over what each of those CRUD operations does. So our first one is, say we wanted to get this information. We'd have to write backend code, which we'll actually show in the next demo. That's going to be a little bit later. But right now, I'll just show all of the, I guess, what some of the main requests do. So if we take a look at our code, we'll see some requests like whenever we access the route, just slash, we want to send hello world. And here we can see it's a GET request, but we'll get into actually like developing that in a little bit. And so if we wanted to kind of just run this GET request without having to like write any of that front end code as we're talking about, we can just create a GET request, give it the route we want it to be, and then if we click send, it'll say some things like, hello world, which is what we told it to do. We can also do something like get all of the people in our database. And that's also some code that is going to exist at this route. So whenever we access API person, that route, we're going to get, I guess, all of our current MongoDB documents. So if we do that now, we can run that GET, and it'll actually return us all of the information that exists in our MongoDB account. So we'll see some things like the cars, the profession, the name of the people, and all of that. So Git is going to be really useful for actually like reading data and taking data in. So data that's in your backend and you want to display on your front end, that's where you're probably going to use GET requests a lot to do those types of features. And then contrary to that, whenever you want to like update data from your front end and put it in your backend, you're going to use something called a post request typically. And we can actually kind of see what that'll do. So if we wanted to create another document in our collection, we'd have to provide a body, which is going to kind of be some JSON as well. So if we wanted to create somebody with the first name, yeah, sure, another person or me, we can go ahead and run this post request, and we'll actually see that after this sends, we'll take a look at what it says. Person named Colperry was added to the collection. So now if we go back into our MongoDB, refresh, we should see that new person was actually added into our account. And then let's say, so yeah, we see it, we see the information we added. And then one final request we'll take a look at is the delete request. And let's say I accidentally added Colperry to the MongoDB and we didn't actually want there. We can go ahead and run a delete request in Postman. And that's going to look like we want to delete something by an ID. We can actually also put that in the body. And again, we're going to look at the code for this in the following demo. But for now, this is just kind of a preview of what we're going to be doing. So we can add that ID and we can send it. And we'll see that the person with that ID was deleted. So if we go back to our MongoDB collection, we'll see that I am no longer there. And it's just going to be that Paul Miller person. And yeah, so Postman is a really useful tool. It's just going to speed things up for you in development if you use it. It's not required to use it, but you can basically have your GET requests, your post requests, your delete requests, and any other types of request, as you can see here. But the main ones are just going to be GET, post, put, and delete. And we'll actually go and create this again in the next demo. But for now, that's just kind of what this will look like. And then any questions with Postman so far? Sweet. So now we're going to move into Mongoose, and that's going to be kind of how we query our MongoDB data.
Very cool. So we'll be talking a little bit about Mongoose now. And so basically what Mongoose is like React, it's just another node package that we'll be downloading with the node package manager. It just gives us a lot more helpful code that we can use without having to write it all ourselves. So Mongoose gives us a lot of helpful things in our code. It'll give us kind of the functions that we need to connect our code, front end, and middleware to like the backend database that we've been talking about and get things linked up that way. And we'll also use Node to host our server when we're developing. We'll talk about that a little bit more in the demo. And then Mongoose also, like Cole and Vance have said, kind of helps us query our data and look for specific documents that we may want in our database. And then it also lets us kind of manage our data, define what it looks like so that we know what types of data to expect in our program and what we'll be working with. So before we jump into a little bit more about Mongoose, we'll kind of talk about just where it fits in relation to everything else we've talked about so far. So we've talked a bit about MongoDB today so far, and this is kind of the core of our backend, right? So this is where all of our data lives. This is nothing that the user is going to interact with, but just kind of the backend of our code we'll see and talk to. Mongoose kind of links that backend more towards our front end and allows our API routes to connect to the MongoDB database. And then using Express, which we talked about last week, we can create those API routes that kind of tell us what we want to be doing with Mongoose and MongoDB, and then bringing data between the front end and back end. Those fetch requests that we talked about in JavaScript, that's going to be closer to the front end. Those are going to be called when the user needs to fetch data or when we're sending data back and forth between the databases and those API routes. And then we move all the way back into the front end with React, which we talked about a few sessions ago. And this is kind of what the user sees displayed on the front end and what they'll be interacting with, manipulating data through that way and seeing the data that's in our MongoDB database. So you can kind of see all these things work together to kind of bring that data flow between backend and front end. And it's helpful to know kind of where we are along the steps of our coding process. So first, how are we going to connect to our database with Mongoose? So connect to our database, it's actually pretty easy. All we have to do is call mongoose.connect in our Express server. So the syntax isn't anything too intense, just one function we have to call. Connect takes one parameter, which is our URL from our MongoDB account. It's a little bit harder to find than like our GitHub URLs. I think we're going to talk about that in the demo. Yeah. So we'll show you all how to get that URL. But that's the only tricky thing about this. And then also connect is an asynchronous function. So we just do want to remember to use that asynchronous syntax that Dan went over last week to make sure we don't get that blocking when we're connecting to our server. So we see the syntax example on the bottom. We could define a URL variable just to hold the string that our URL is. So inside those opening and closing brackets, you just put whatever URL you get from MongoDB to connect to your database. And then you can call mongoose.connect, put the URL in there, and then with a then statement to get that promise from the async function, you can just maybe spit out a message saying that you connected. That way you know you got the result you were expecting. So it's pretty simple to connect, and Mongoose is really helpful for connecting that way.
Yeah, so before we can start getting into actually writing CRUD operations with Mongoose, we kind of have to go over schemas and models, which is how you define a collection within Mongoose. So a schema defines like the data fields and all their types. So that's kind of, you can think of it very similar to like where you define a class. So like this is the data structure that you're working with. And then a model, this will make more sense when we go to the example in the next slide, but a model kind of connects your schema to like your MongoDB collection. And then just a little aside on like file structure for like just backend in general, we typically want to have each schema and model go in their own file, and then all the API routes for a collection also go in their own file. And then we have like the general Express like hosting file. So in this code example, this is like one complete file for defining a schema and a model. So top line, we're just going to import Mongoose. Then that next like data definition where we define the event schema, we're going to make a new schema with the mongoose.schema function and just pass in an object where we say name is a string, topic is a string, and date is a date. So that's just defining a couple of fields for that data type. And then line 9 is where we define our model. So that's where you kind of call mongoose.model. And then the first argument, I believe, is going to be like the name of your collection in MongoDB. And then your second argument is going to be the schema that collection follows. And then finally, you're going to export that event so you can actually reference it when you're making CRUD operations. So CRUD operations in Mongoose. So we know what CRUD operations are, but now we actually have to know how to make them. So in that demo Cole gave earlier, we had like an API route that we were calling that would like take data from MongoDB and send it, but you actually have to write those routes yourself. They're not given to you. So the first CRUD operation create, there's kind of two ways that you can add a new document using Mongoose. You can either use the event or in these examples, it's going to be event, but event is just going to be whatever model you're using. So there's two ways you can use the create function where you just pass in an object that follows the schema, or you can use save, which kind of breaks it up into two steps where you first create like a new instance of that model and then you save it. The effect is going to be pretty much equivalent. It's just a preference thing. But yeah, that's how you create in MongoDB. Next up, read. Read is very important. So there's lots of different ways to do read. So the most general, like helpful function to use is find, which will write a query. And for those that don't know, a query is just like, it's a search. It like when you go onto Google and you type it in the search bar, you're making a query. So your query is just going to be an object. So there's like 4 examples here. In the top left example, we're going to call .find, and we're going to pass in an object that says topic is MongoDB. So what that's going to do is it's going to look in your event collection, because it's event.find. It's going to look at the topic field for every single document in that event, and then it's going to return all the events where the topic is MongoDB. So that's where you can get like 0 or more, because there may be no documents that have MongoDB as the topic, or there may be like 50. And then if you want to just take all of the data from a collection, you just make that query empty. So that's the bottom left example. And then if you're looking for like one specific thing, it's like if you already know what recipe you want to use, but you don't like have that data on the front end yet, that's where find by ID and find one come in. Find by ID, you just pass in the object ID. So that's typically, if you already know the ID, that's like the safest way to do it. Or if you don't know the idea, but you know the name of the recipe, or in this case, if you know like the topic of the event, you can just pass in a query and it will only return the first document that like matches that query. So very useful functions. Get is going to be like or read is going to be like the main API route they're going to be using a lot, because you need data on your front end. And then update and delete. There's a couple ways to do that. There's find by ID and update, which it's pretty self-explanatory. Your first argument, you're going to give the ID, and then your second argument, you're going to say like what field you want to change. And then find by one and update, it's similar to find one, where your first argument is the query instead of just the ID, and then the second argument is going to be what you're updating. So if you look at that code example to the left, the query is topic MongoDB. So it's going to find the first document where the topic is MongoDB, and then it's going to set the date for that event to be November 8th, 2021. So update is kind of like syntactically the most tricky, just because there's 2 things you have to remember. You have to remember what you want to change and how you want to change it. And then delete is pretty straightforward. You either pass in an ID or a query, and then if it matches, it will delete it. So in the code example to the right, if it finds an event with that ID, then it will just remove that from your database. And then all this documentation is online. So if you ever get lost, because Mongoose documentation is pretty good, but it's not the most intuitive, just go to this slide and you can find all the useful links here.
And sweet, we should be moving into the final demo. And this is going to be putting a lot of what we've seen on the slides today together. It's going to go over kind of connecting your MongoDB cluster into your code. It's going to go a little bit over writing API routes, and then we're going to go into testing that with Postman. And so the first thing we'll do is we want to connect our data to our code. So I guess before anything else, I already wrote a lot of the code for this, and that was useful for our Postman demo. So we already see I already have the kind of URL and connection here and some other things as well. But we're kind of going to go over it and show how we would do that if it's not already there. And so the first thing you want to do is you actually want to go to your cluster, and there's going to be this option to connect. And so I'll also talk a little bit about creating an Atlas account. You'll have to create an Atlas account, which again, we'll go into details when you actually have to do it in the project. We'll kind of walk you through that. And then you'll also have to create I guess, permissions for who can access your cluster. And if you're creating your own cluster, you'll have to kind of create kind of another account, which is just going to be who can actually access this cluster. So I already created my Atlas account, and I've already connected my cluster account, but we can actually go ahead and hit the option to connect, and we'll see kind of what we can do if we have already created those two things. So there's going to be some options here. The one we're going to want to do is just connect to your application, the one in the middle, and that's actually going to give us just a string here. And there are some things to note. So in the cluster, you have those permissions for who can actually access your cluster. And so I created an account, db user col, and then I created a simple password, which I'll show you in a second. So we'll have to go in and change this once we connect to our URL. Cluster 0, you're gonna wanna make sure that's the name of your cluster. That's what it is by default. I've never really changed my cluster name, so you probably don't have to as well, but if you do choose to, you can change this here. And then the database you wanna connect to, those are gonna be the things you're gonna have to actually change from this URL. So if we wanted this, we can go ahead and copy it and go back to our code, and we can actually put it here. I'll comment this one out, and then I'll show what it would look like if we wanted to connect to it. I'll also go ahead and comment out how we connect to it, and we'll kind of do that from scratch. So if we start our server, this is going to be our Express server. There's not, oh, I didn't save it. Nothing's going to happen. It's just going to be a started server. So if we want to, we can have our URL and then post that in from MongoDB. So we're going to have to change some things. The password is the first thing. I named mine DB password. And one actually important note is during the milestone, this password is going to be visible. So make sure, and that's just going to be so we can actually review it and like kind of use this cluster to test your code. So don't make it your own personal password unless you want me to hack you, which is a good option as well. And then we need to change our database. And we can go ahead and see what that was called by going to our collections. We can see I have 2 databases, but the one we're going to connect to in this example is this example for demo. That's not a great name. I probably should have named it something better, but we can go ahead, put that here, and we should have our URL set. And then we're going to have to actually connect to this. So if we do that mongoose.connect URL, we can actually go ahead and have that connection, but we do want to make sure that it works. And so to do that, we can add like a .then, and that's going to be a function, and we'll just have it say console.log successful connection to MongoDB. Go ahead and change that. And if we refresh it, we see that there's a successful connection. But one thing that is good is we want to catch any errors. So similarly, we can have a console.log where it says failed. And this is going to be important for connecting to it, because if right now it's successful, but if we change the URL, we should be able to see that it's going to fail. And that's going to be helpful for debugging and making sure that you're not like going crazy because your code's right, but the connection's wrong. So I just want to make sure that you make sure to log that correctly, and it should work. And then we'll go into the schema. So as mentioned earlier, we saw this person, and it's going to have some things like a first name, a last name, phone, city, cars, and profession. And we actually have to define what that schema is in our code. So I called it person schema. It has first name, last name, phone, city. Those are all strings, whereas profession and cars are arrays. Profession, if we go take a look, is going to be, I guess, an array of strings, and cars is going to be an array of objects. So in our code, we're going to have basically by having like the string, and then you'll want to put your type in there like that. And that's going to be how you define your schema. And then is you're going to have an option here to add your collection here. Back here, we have our demos is the database name. And then here, demo is the name of the collection. And so you're going to want to put that in your schema as well. And then here is where you will actually kind of create a person instance. So if you're familiar with object-oriented programming in Java, now you kind of have access to using this person schema and what that will look like. So that's kind of creating the schema. Typically, this isn't going to all be done in your index.js file. You'll have kind of a place to put your schemas, and you'll have a place to put your routes. For this demo, though, we're not going to have that many. We're just going to kind of we're only going to use this person schema, and we're only going to use a few routes. So they're all just in the index.js for now. Go ahead, save that. Nothing should change now. And here we're going to see our first request. That's going to be a GET request. And if we go into our Postman code, that was what happens when we get this default route. It's just going to say hello world. We can change that to whatever we want. Hello all. Change that, save it. And then if we go ahead and send, it should say hello all. Some more interesting ones is here we'll actually see a Mongoose query, and that's going to be find. So this is the first Mongoose command we've ran into. And if we go to the route /API/person and actually kind of get that route, we can just kind of see what happens, and it gets all of the people in there. And this one's, again, it's not that interesting. It's just using find, which finds everything. That's probably the easiest query to write in Mongoose. But moving forward, we'll go into a slightly more challenging one, and that's going to be our first post request. And so in your post request, it's again going to be at the same route. We're going to have a lot of stuff in our body. So in Postman, you'll have, I guess I'll show what it looks like when creating a new route or a new request in general. So let's say we want a post request. Let's save it as well. Get all or create a new person. And this is going to be a post request as well. So we have some options here, some things like params, auth, headers, body. Typically, when we send large amounts of data, we're going to do that in the body of a request. And you can get to that by here, clicking on the body tab. And then you're going to see like some types. So we're going to use raw and then change the type to JSON. Then I'll actually go ahead and copy just all this JSON data because it is tedious to write if you're doing it by hand, but it should be done in your code, so you will have access to it here. And then you can go ahead and post that in. And we also need the URL, which we set was /API/person. So it's going to be HB localhost 3000 and then API/person. So we have our body. We can add headers if we want to. By default, these are going to be the ones that are always added into a default Postman request. But sometimes you might need something like if we only want to be able to make this request when somebody is authenticated, we could add that header here. We're not doing that for this example, but that might be something that's used once you're with your nonprofit teams. So we can go ahead, run this post request, send it, and now it will actually be, again, in our MongoDB cloud. So now we should see two people. So we see Paul, and then the me I was just created. And yeah. So now moving back to the code, we can see kind of how we get that data from the post and put it in the database. And that's what we're doing here. We have the request and the response. And if we remember in the Postman, we had all of this in the body. And we're actually going to need to access this within our code. So we're going to need things like, we're going to be able to have to get the first name, and we're going to have to get the last name and all of this information. And we do that in our code by kind of setting these variables here, first name, last name, phone, and getting all those. We're setting those all equal to request.body. That's one way to do it. Another way is we could do something like const first name is equal to request.body.first name. And that will just kind of be the first name. If we didn't want to do that, but since we are getting a lot of information, we can just kind of set all of these to have request.body to start, and then that kind of gets added to each of those here. And that's just a syntactical thing that makes us write a little bit less code. Yeah, so that's going to be what a post request is going to look like. Remember, we saw the save function, and that's going to be what actually writes your code into the database whenever the save is ran. If there was an error, it would just throw it. Typically, all of your requests you're going to want to add error handling to, and that's just going to look simple, either a try catch, you can do it like that, or you can just have it return errors, which should be done by default through HTTP requests. And then one more I'll talk about is the delete. Here we use another Mongoose query. We use find by ID and remove. Again, it's going to be at the route API person. Actually, one thing I haven't talked about here is this like person is actually getting the schema and telling us what schema to use. So it's going to look for the person schema, and then we're going to look for by ID and remove. And then we see kind of here what that ID is. So in our code, we put the ID we want to delete here. And that's convenient. If we put that in the body, we can access that by request.body.id. Or if we didn't want to do that here, we could actually go ahead and manually like put what we want in, or how we want to access it here. I think the syntax might look a little bit like this, although I don't remember off the top of my head. And we can delete it like that as well, without having to use it in the body. So that way we wouldn't need this at all. We could just go ahead and save it. This might throw an error, which could be a good learning technique. But if we make sure it's saved, this.
Yeah.
Oh yeah,
just
because
pass
it's
it
an
out.
ID and remove, it just needs to be the string. And then we get an error. Yay. Did I throw the error? Let's see what it says. Cannot read property 1 of undefined. We'll go back to how it was before. With the request.body.id and putting that here. And if we actually look at our MongoDB instance, we can see, make sure that it wasn't deleted and then an error was thrown. I probably should check that in the code, but let's get this ID. And then if we go back to our Postman, put that here, and then now it should be deleted. And again, that's just getting the body ID and removing it. So if we refresh our MongoDB, that should now be deleted. And then one final kind of thing before we wrap up is I'm actually going to go ahead and create a route from scratch. And this will just kind of be helpful for seeing how to actually do it yourself. So we'll just do a GET request, and let's say we want to get everybody whose name is Paul. I'll go ahead and add another person back in just so we see that only Paul's got. So now I should be back in the database. And we can kind of run a similar query here. So we're going to do a GET request, and let's say we just want to get all people or the first person named Paul. We can do that by writing our query. We'll just set up some of the boilerplate code for now, and then we'll go ahead and fill in some of the parts in a second. So what we're going to want to do this at a route API person. And then if we remember it last week, we can actually do something like have a variable here or something unknown here. And then we're going to want this to be asynchronous as well. So this is just going to be setting up the route. I'll go ahead and create it in Postman in a little bit. And then we need to actually access it. So it's going to look something similar like this, where we create a variable and then we do it. I'll just call it Paul because he is who we want to remove. Person dot find one. Yeah. And find one, just going to find one. And then we have to tell it what we want to find. So we want to find something where first name is going to be, now bear with me here, it's going to be the request dot params, which we haven't talked about too much yet. We did a little bit last week, and it's just going to be, we can access it through the URL as opposed to a body. So if we added something like person is equal to Paul, that's at the wrong route, but that will mean we can access Paul by going to the first name in the query parameters, which is just going to be in the URL. So we can do that, and then we can actually send our answer if it works, and we can just do send Paul, I guess, for this example, and maybe a message as well. Paul was removed here, like so, and then our route should be created. But one thing we have to do now is actually test that this works in Postman. So we can go ahead, create a new route, HTTP request. We'll get, we want it to be a get because we're getting Paul, and then it's going to be at HTTP. I'll just get this one, and then I'll modify it. Where to go? Here. Oh shoot. This one. This one. HTTP localhost API person, and then we're gonna add that first name equals Paul. We could also do that just by adding it into the params. So if we didn't want to do it like this, we could add one here. We could do first name equals Paul, and that should work as well. Finally, we should be good to go ahead and send this request and see what happens. And if we look, we actually see that we just get Paul. We're not going to get anything else, I believe. Find one. Yeah, we're going to get the first name where we get Paul. And we can see that when we do that, we get Paul here. I get that was a lot. We'll make sure to like post a lot of the demo and some of the slides as well as all of the code that was written. I'd strongly suggest kind of like looking at some of this code before you start working on your milestone, and actually while you're working on your milestone, have some of this pulled up, and it should just make things a little bit easier. You're going to be getting, there's a lot of different information we learned today. We learned a little bit about MongoDB. We learned about Mongoose. It's still, if you aren't too familiar with Express, you have to incorporate that. And so this is kind of has a lot of moving parts, which some people can find hard, but having a good example should be helpful for looking at. Moving back to, I guess, our slides. We're almost done for today, but there's a few left, and it's just going to be a CRUD review. So that's going to be that create, read, update, and delete. So those are just going to be kind of like the CRUD operations are those create, read, update, deletes. And then the HTTP method that goes associated with those CRUD operations. If you're going to be create, you're going to be, you write a post request, and that data is going to flow from front end to back end. So some functions you can do in Mongoose are going to be create or save. I won't go over all of these because it's just a table, and it's more here as a resource. But if we wanted to do like a read operation from CRUD, we do a GET request, and that data is going to flow from the back end into our front end. So it's going to flow from our database into our like React app. And some of those Mongoose functions are find one, find by ID, and there really is a lot more. We can't go over all of them, but we do provide the resources, and that should be good for now. Finally, just wrapping up, reminders. We have our holiday on Thursday. I think it's Veterans Day, so no boot camp. Hopefully you guys can use that time. Make sure to work on your milestone, as that's going to be due this Friday. Again, this is going to be over React and creating components with your code. So make sure to get started on that. That can be a tricky milestone. It might be the most time consuming if you haven't used React before. I'd strongly suggest getting started on that before Friday at like 4 p.m. And then a reminder, Vance will still be holding office hours on Thursday. Those are going to be 11 to noon, so 11 a.m. to noon, I believe. If you're stuck on the milestone, want any help, just make sure to come by our office hours. And then we'll also be sticking around a little bit after, or I guess right now, if anybody needs any help with any of the milestones as well. And then finally, there's that Chipotle fundraiser, which is going to be happening next Tuesday, I believe. Maybe it's 2 Tuesdays. That's in the Slack. And just everybody loves Chipotle, so go show them the flyer, and Hack for Impact gets some of the profit. So yeah, miss anything?
Yeah. Last in-person boot camp is a week from today.
Yeah. Does anybody have any questions about any of the material we went over today before you guys are dismissed? Sweet. So thanks for coming out. Again, almost done with boot camp. Really good job making it this far. We get it's a lot of material and it's covered very quickly, but hopefully it's very helpful and provides some information that you won't learn in your classes. Stop recording. Stop sharing.